Okay guys, so this video is going to be on these things called motion diagrams. Now these are not in your book. This is something that I like to teach to my students when we start to study motion where there's acceleration. So up till now we've been looking at situations where the object is moving at constant speed and constant velocity. So it's moving with the same speed in the same direction, and we know that the distance it travels will be its velocity times its time. And so we worked problems, looked at graphs and all that. Now the next kind of step in this course is to look at motion where the velocity is not constant with time. So it'll change with time, and we say that it accelerates. Now, one of the hardest parts about looking at things that are accelerating is determining what's the direction of the acceleration. As we'll see in class, a lot of times we want to point the acceleration in the same direction as its motion, as it's moving, and that's not always true. So motion diagrams help you see the direction of the acceleration. So first of all, what is this motion diagram? So if you imagine, say, a ball dropping and a ball being launched this way, and if you had a camera and you're taking pictures of this, and the shutter was clicking, and it put all the pictures on the same, put all the exposures on the same frame, what you would get is something that looks like this. You could see the ball falling over time, and they're all kind of stacked onto each other. If it's launched, you would see that as well. And what a motion diagram is you make it by thinking about the motion, thinking about how the position of the object will change with time, and then putting a dot at a position every second or so. So say that this was, taking a picture once every second, and when it's dropping straight down, I put a dot where it starts, then it's going to fall a little bit, and because of gravity, it's going to fall faster and faster, so the next second it's going to fall a bit further, then a little bit further still in the next second, then a little bit further still in the final second before it hits the floor. If it's launched, we can do the same thing. You just put a dot at its position every second. Okay, so the important point is that the time interval is constant in the motion diagram. Okay, so that's going to be 1 second, and this is going to be an additional second, and this is going to be an additional second. Okay, so that's the first thing to understand with motion diagrams is the time between the dots is going to be constant throughout the whole thing. It doesn't have to be a second, but it is convenient a lot of times it is. So if it was just a matter of making dots and knowing that it's the same time between the dots, motion diagrams really, honestly, guys, wouldn't be super useful. But what makes them super useful is they allow us to get the direction of my velocity and the direction of the acceleration. And when we start using equations that have velocity and acceleration, it's going to be very important that we know when they're negative and when they're positive. And motion diagrams help us see that. So to help us practice this and to show you how it works, I have this situation here where we have a car accelerating, traveling at constant speed, then applying our brakes and slowing in 5 seconds. Now, the first thing we do is we need to define what direction is positive. And so in my answer keys, a lot of times you'll see me put an arrow with a little plus sign. That's telling you guys what the positive direction is. What am I going to consider to be positive? Now this is just one dimension, so we only have to specify one dimension. If it was 2 dimensions, later on the course we'll consider balls flying through the air, both up, down, and left, right. We have to do whether up or down is positive. But anyway, in this case, we'll put to the right's positive. And the car starts off, and this is going to be my t is equal to 0 seconds. And then 1 second later, it's going to go, and because it's accelerating the forward direction, it's going to go a little bit further each time. Okay, so this will be 1 second, 2 seconds, 3, and then 4. So this is 4 seconds. Now it's going to travel at a constant velocity for 3 seconds. So I want to keep this spacing the same, because the velocity is not changing. So I'll indicate that by keeping the spacing the same. Okay, so this will be 5 seconds, 6 seconds, 7 seconds. And then it says it's going to slow down and stop in 5 seconds. And so it's going to get a little bit closer each time. So that's 1, 2, 3, 4, and maybe 5. Okay, so over the next 5 seconds, so this is acceleration for 4 seconds. Whoops. Constant speed for 3 seconds. constant speed, and then slow down for 5 seconds. All right. Why do I get different colors here? Let me see. Oh, I can. Awesome. All right. So here's the deal. Between each of these dots, I can define a velocity. Okay, so I can say that I can use this arrow. Okay, so these blue arrows are going to represent my velocity between the two positions. And notice that they're getting longer and longer and longer. Okay, I'm not going to write V's for each one of them, but these arrows get longer and longer. So these longer arrows mean that the velocity is increasing. These arrows are called vectors, and we're going to come across vectors quite a bit in this course. And I'll talk more about them, later on. But for right now, just realize that these are vectors. They have a direction, and how big the arrow is tells you how big the velocity is. The longer the arrow, the greater this velocity. So as the arrow gets longer, it tells us that the velocity gets greater with time. And on top of that, it tells us by the way it points that the velocity is positive because it's pointing in the positive direction. And then here, I'm going to have a constant length. Don't use a ruler to do this, so it might not be perfect, but I have a constant velocity, so I'm going to have 3 arrows of constant length here. And then I'm going to have an arrow, and now they're going to get shorter over time. Okay, so like that. Okay, so all these blue arrows are velocity. Okay, make a little key here. So this equals velocity. Okay, and so the direction of the arrow tells you what the sign of velocity is. It's positive. The way that the arrow is changing is going to tell us acceleration. Okay, so my acceleration, what color should acceleration be? Let's make that, I guess yellow. All right, so here's the thing with the acceleration. If you notice that the length of the velocity arrows increases, then the acceleration points in the same direction as the velocity. Okay, so if velocity, I don't want to patronize you guys, I'm going to quit calling them arrows. If velocity vectors increase in length, acceleration vector points in the same direction as the velocity. Okay, so as the velocity. So you notice here they're increasing length. My acceleration points in that direction, and my acceleration for this part's positive. In here, the arrows don't change in length at all. When that happens, the acceleration is 0, and the units of acceleration is meters per second squared. So if the length remains the same, my acceleration is 0. It's not accelerating, okay, as far as speed goes. Later on, we'll talk about how we can accelerate with the speed being constant, and that's if you change the direction of the arrows. But don't worry about that now. This one's interesting. Notice that here the arrows are getting shorter and shorter and shorter. When that happens, the acceleration points in the opposite direction from my velocity. Okay, so if velocity vectors decrease in length, acceleration vector points in the opposite direction. From the velocity. Okay, so these velocities are all positive. They're all pointing in this positive direction, but because they're decreasing in length, my acceleration is pointing to the left. This would actually be a negative acceleration. Okay, but again, I can see that because I made my motion diagram, I drew my velocity arrows, I noticed that they're decreasing with time, they're decreasing in length with time, which means my acceleration points in the opposite direction. Okay, so we're going to practice this in class, guys, and you guys are going to have a lot of practice just drawing these motion diagrams and making sure that you got this down before we move on to using equations. So, put my little legend here. So this one is acceleration. Okay. So anyway, I hope this made sense. If you guys have any questions, please let me know in class, and I will see you soon.